Right, good afternoon, everyone. Once again, my name is Hendrik Makaneta, and we are going to learn mathematics today, grade 8, on the 3rd of July. And of course, please feel free at any time to chat, just to send a message, or if you have a question at any time, please feel free to ask. The group chat is quite open and active. I noticed that the majority of students prefer to rather ask questions there. Right, today's lesson is going to be based on common fractions, and we will also talk about equivalent fractions, and of course we will also have some questions, word problems that we are going to do, which involve fractions, and we will hopefully simplify some of the fractions. And of course, this is the lesson taking place today on the 3rd. Right. Without any waste of time, I just want to zoom directly now to define a fraction. A fraction can be defined as a portion of a whole. I'm sure you know the examples, some of which you have already done in previous grades, like grade 6, grade 5, they were introduced there, the early grades. But I think even in grade 7, you might have done when you divide a cake, for instance, you know, the entire cake is known as a whole because it is complete. And once you divide it into two, then you know that one person can get half of the cake and the other can also get half. I see that Lesedi has given an example. Yes, 1/2. That is also a half. And then, of course, it's very important to also realize that, you know, we can have equivalent fractions, meaning that fractions which do not look exactly the same, but they may have the same value. For instance, I have an example here where I've put in 90 out of 100. And we say that 90 out of 100 is the same, or it's equivalent to 9/10, meaning that the two fractions are equal, because if you take the 9/10 and multiply it by 10/10, you will get 90/100. That's how you get the equivalent fraction, because 10/10 is just the same as 1. So when you multiply 9/10 by 1, or by 10/10 rather, it means you do not change the value of your fraction. The value of your fraction is still the same, because this is the same as multiplying 9/10 by 1. So the value hasn't changed, and I hope that it will make sense even as we proceed, because we are going to, as I've already said, we will get some of the word problems where we are going to need to take our pens and papers just to solve the different activities. So the starting point for today, I just wanted to bring you to the attention of equivalent fractions. And there are many different fractions, or rather equivalent fractions, which you can think of. So 90/100 is the same as 9/10. And then I will come back to this equivalent fractions when we deal with both the proper and improper fractions. So the next slide, I'm going to zoom directly into proper fractions. And as you can see, we are defining the proper fraction as follows. We say that when the numerator is smaller than the denominator, then the fraction is known as a proper fraction. So it's proper fraction because the numerator is smaller than the denominator. Once again, if the denominator, in fact, if the numerator is bigger than the denominator, then the fraction is known as an improper fraction because the numerator will be bigger than the denominator. So we are now going to zoom directly now into the proper fractions. So I'm giving you just several examples, and I'm sure that you can think of many other examples in addition to the ones that I've mentioned here. The first one is 5/7. Excuse me, 5/7. And of course, we say that this is a proper fraction because the numerator is 5 and the denominator is 7. You can look at the numerator there. The number at the top of your fraction there is known as the numerator, and the one at the bottom is the denominator. So 5/7 is one of the examples of a proper fraction. Now, in the same note, 2/9 is also a proper fraction, and the fraction that was given by Lesedi, I see Boutle wants us to repeat. Lesedi also gave us the fraction 1/2. That 2 or that fraction 2 is a proper fraction because the numerator is 1 and the denominator is 2. Other examples include 2/9, as you can see there in the examples. We also have 32 out of 35, 78 out of 120, and then you also have 12 out of 1,000. So these are proper fractions because the denominator is bigger than the numerator. So even in your case, when you have your school marks, at times you may get your results and say, for instance, you wrote a test out of 50 and you scored 26 out of 60 there. Out of 50. Then it means your fraction there is a proper fraction. So when you do or write your exams, you will always have a proper fraction because unless you get 100 out of 100, that is it's no longer a fraction. It's now 100%, which is 1. So if you get total, that's 1. But other than that, you will always get a proper fraction. There is no way in which you can get an improper fraction when it comes to your marks, right? And then, of course, we also have the improper fractions. But before we go to the improper fractions, I want you to just use the example that I've given you now, which is 5/7. I want you to give me now the different equivalent fractions. 5/7 is one of the fractions. And then, of course, you can be able to give me equivalent fractions. I like the comment that you have just made, Lisedi was asking, what do you call a fraction that has the same numerator and denominator? So the group chat, I can see Natalie has already answered you that it is called a whole. Yes, it is called a whole because like a cake, if you eat the whole cake, then that fraction is the same as 1. You have eaten 100% of the cake. So it's called a whole number or a whole. So now I want you to give me the equivalent fractions of 5 over 7. And I can think of many different fractions, but I want you to list at least 3 different fractions which are equivalent to 5 over 7. I hope that it makes sense. You can list as many as you can, but in this case, I just want you to give me only 3. So in the absence of the answer, I will just proceed to demonstrate that when you have 5 over 7, in order to get the equivalent fraction, you can multiply always by a whole, by 1. So meaning that you can also multiply 5 over 7 by 2 over 2, for instance, meaning that you multiply the numerator by 2, and then you also multiply the denominator by 2. So whatever you do in the numerator must also be done in the denominator so that you keep the value of your fraction intact. I can see Nhlanhla has already solved the first one. Nhlanhla says 10 out of 14. Yes, I agree with you, and Nhlanhla, that is an equivalent fraction. Yes, definitely. 10 over 14, sorry, not 15, but 14. 10 over 14 is an equivalent fraction to 5 over 7. And I can see you've probably multiplied by 2. And then the next one, I see that the next one, there's someone there saying, Natalie once again says 25 out of 35. I fully agree with you, Natalie, because if you multiply 5 by 5, you get 25. And then if you multiply 7 by 5, you get 35. So the other equivalent fraction will be 25 over 35. Right, that's the correct answer. Can I get just the last one? I see Guguletu Zwane has also chipped in to say 3 out of 5. As Guguletu says 3 out of 5. Let's see, is Guguletu correct to say 3 out of 5 is the equivalent fraction? How did you, maybe the question should be, how did you find 3 out of 5? Guguletu, how did you find 3 out of 5? Right, Nhlanhla says 50 out of 70. Yes, I agree with Nhlanhla, the 50 out of 70. And then the other one, 15 out of 21, comes from Guguletu. Yes, so you have given me more than 3, and thank you very much indeed for participating in this activity. So yes, I fully agree that 50 out of 70 will be, and then 15 out of 21, yes, that's correct. Then of course, I can see that 5 into this goes 3 times, 5 into 21 cannot go. So the other one where you have 3 out of 5, I don't agree with you. 3 out of 5 is out of the picture. That is not the equivalent fraction. So please try to check it, Google it too. But when you say 15 out of 21, I agree with you. Definitely, that is the correct answer. Yes, we have now given the different, or rather the equivalent fractions, equivalent to 5 out of 7. Now is the time for us to zoom now directly into the next type of our fraction, which is now called improper. So we have just defined the improper fractions. We've said that this is 8 out of 3. But this is just the baseline, just to introduce you once again to the fractions. And 8 out of 3, it's called an improper fraction because 8 as the numerator is bigger than the 3, which is the denominator. So we have said it when we started the lesson that if the numerator is bigger than the denominator, then it means we now have the improper fraction. Before we can carry on quickly, can we now get just 2 equivalent fractions to 8 over 3? Just 2 equivalent fractions. I'll be happy if you can just give 2, and then we can move so that I can tell that you understand what is happening. Just 2 fractions that are equivalent. I see and Tantla says 2 wholes and 2 over 3. So now, Tantla, what you have done there, you have given us the mixed number. But what I actually want is just the improper fraction. The improper fraction, which is equal to 8 over 3. I see Guguletu says it will be 16 out of 6. So meaning that if you multiply 8 by 2, you get 16. And then if you multiply 3 by 2, you get 6. Definitely, I fully agree with you, Guguletu. That is the correct answer. And then Ntantla also says 80 out of 30. I fully agree with you, Ntantla. That is also correct. I see Lucedi has given the mixed number. That's okay. It's fine to give a mixed number. But in this case, I was looking just at the improper. So you can take back, if you take the mixed number back, you'll multiply 2 by 3 to get 6 plus 2. It will be 8 over 3. So what you have done, you have just solved or rather simplified the fraction. The last one will be Guguletu, who says it will be 40 out of 15. And of course, if you multiply 8 by 5, you get 40. And then if you multiply 3 by 5, you get 15. So yes, Guguletu, that is the correct answer. And those are the examples that I needed in as far as the equivalent fractions are concerned. So now I'm going to, before we carry on, just to show you, we have got several other improper fractions, such as 12 out of 7, 32 out of 5 there, and then 327 out of 12. And then, of course, the last one there is 1,000 out of 13. So those are improper fractions. So let me not waste a lot of time on those. Let's now check that the improper fractions, as Lesedi has done, can be written as mixed numbers. In other words, if you are to write 12 over 7, for instance, as a mixed number, you can just check how many times does 7 go into 12. So we can all agree that 7 will go into 12 only once, because 7 times 2 is 14. So 12 is less than 14, therefore 7 goes into 12 only once. So you write 1 there, and the remainder will be 5, because 12 minus 7 is 5. So the remainder is 5 out of 7. So this gives us now the mixed number. And of course, all improper fractions will definitely give you a mixed number or a decimal number there. But of importance, the mixed number is the one that we get when we solve any improper fraction. Then it is followed by 32/5. And then, of course, again, you can tell that 5 into 32 goes 6 times. It goes into 30 without a remainder there, but into 32, then there will be a remainder of 2. So the answer, or the mixed number rather, will be 6, which is now a whole number, and then 2/5. So that will be our mixed number there. Without any waste of time, I hope that you understand these important fractions, the improper fractions, the manner in which you can write them as mixed numbers. So we are now going to zoom into some different fractions which I want simplified. I just want us to simplify this 3 out of 25. When you look at the fraction, you can tell that it is already simplified, but you can simplify it further. Remember, when you simplify a number, you need to write it in such a way that it can no longer be simplified further. For instance, you have 3 in the numerator there, and then you have 24 in the denominator. So I see that several learners are busy now, and Tlantla, Lesedi, and Cesar. All of them say the simplified version will be 1/8. And how do you get 1/8? Maybe if someone can explain. I just want to test your knowledge. How did you find 1/8? Maybe one of you can share with us, Lesedi or Guguletu or Cesar. Just please share with us. All right, Ntantla has already come in to say you divide by 3, okay? Yes, you divide every value there by 3. In other words, the numerator, you divide the numerator by 3 to get 1. And then you also divide the denominator by 3 to get 8. So 1/8 is the correct answer. Cesar also agrees that you divide 3 by 3 and you divide 24 by 3. Buhle Mlongwa also agrees with us that you just have to divide by 3. Right, we will not waste a lot of time on that. And you can see, of course, that the 1/8 is the correct answer because you simply divide by 3 in each case. Now we also have the 12 out of 60, which I just want us to zoom directly into and simplify. Can we simplify 12 out of 60? And by the way, there are many ways to do this. Of course, Ntantla says you need to divide by 5. Ntantla, I'm not sure if you are talking about the 12/60. If you divide 60 by 5, right, I can understand that, but can you really divide 12 by 5? You cannot divide 12 by 5. I see Buhle says that we need to divide by 6. Yes, thank you, Ntantla. I'm glad that you have seen the misconception there. Cesar says you can also divide by 12, and I fully agree with you. Ntantla meant to say 6. Yes, I agree. Buhle also says, or divide by 2. I agree with you, Buhle. In actual fact, Buhle's approach is the best approach in my view, because I always tell the learners that, you cannot eat the whole elephant. You need to cut it into pieces. So the best thing is to use the smaller numbers just to divide each time. So if you divide by 2, that's okay, but remember you'll have to get a new fraction which you must further divide. For instance, if you divide 12 by 2, you'll get 6. And then if you divide 60 by 2, you'll get 30. So it means you'll still have 6 out of 30. You still have to divide. And again, you can divide by 2 up until you get the right or final answer. Now, most of you have found the correct answer. Gugulethu, together with Lesedi, says the final answer, or the simplified version, will be 1/5. And then they divided both sides by 12. Yes, I fully agree. If you divide correctly by 12, if you divide the numerator by 12, you get 1. And the denominator divided by 12, you get 5, because 60 is the denominator. So if you divide 60 by 12, you get 5. So yes, the final answer there will be 1/5, as reflected by Gugulethu Lesedi as well, as said it's 1/5. Right, and Ntlanhla also says you can divide by 3. Yes, I agree with you, Ntlanhla. You can divide by 3 as well. The most important thing is that you must divide with one of the factors of the two numbers. The factor of 12 as well as the factor of 60. So 3 is a factor of 60. And in the same note, it is also the factor of 12. So you can divide by 3. Now, the next one, of course, is 32/5. And this can lead now to a mixed number, as we have shown in the previous example. And I think if you have noticed, we might have dealt with this fraction today. 32/5, right? Buhle Mdlongwa is still trying to divide. Okay, you were talking about the previous one, 12/60, which is, you have said that you divide by 2 to get 6/30. Yes, I agree with you. And then divide by 2 again to get, okay, divided by 3 to get, it should be 2/10, not 3/15. It should be 2/10. Hence, you got 1/3. Natalie says it will be 6. We are now talking about C, 32/5. Natalie got a whole number 6 and then 2/5. I fully agree with Natalie. Cesar as well agrees, together with Ntlanhla and Lesedi. 4 people have already agreed with the same approach of the mixed number, where you find out how many times does 4, or 5 rather, go into 32. And you'll see that it goes into 36 times. So it goes 6 times, goes into 30, and then the remainder will be 2. So the remainder is 2/5. And then we also have D. In D as well, you'll see we have an improper fraction, in a sense that the numerator is bigger than the denominator. So the numerator is bigger than the denominator. And then again, you can be able to find out how many times. Natalie has done that already, and she found 9, one whole number there, whole number 1, and then remainder is 9/20. Gugulethu as well agrees with Buhle and Natalie. They too have found whole number 1 and then 9/20. That's correct, because 20 into 29 goes once. Remainder is 9 then out of 20. And then you can see that this is how we have solved it. 1, and then, excuse me, it should not be 1 there over 20, it should be 9. So the last one there is 9/20. So right, the last one is E, which is now 9/6. Again, this is a whole number. This rather an improper fraction, which can lead to a mixed number. I see that Lesedi has already done the first one there. In fact, Buhle and Ntlanhla found the correct answer, 1, whole number 1 there, and then 3/6. I fully agree with you, because 6 into 9 goes once, remainder 3/6. So the final answer will definitely be a whole number 1 there, one whole number, and then 3/6. If you want, you can simplify even the 3/6 by writing 3 into 3 goes once, into 6 goes once. So you left 1 and then 1/2. This is the same as 1.5. 1.5 is the correct answer there. And I see that Nhlanhla got that right. Gugulethu also got it right. Thank you very much, Lesedi. I acknowledge your input. So this brings us to the end now of trying to simplify the fractions, be it through mixed numbers or just to simplify the proper fractions. So we have done that now, and then we can now build up or build on the lesson. But before we get there, let's do just the last two. I'm going to give you now F and G, and then this will be the last two fractions which you need to simplify. We have now F, which is 45/8, and I want us to simplify this particular activity. Right, Buhle, I don't know if you've answered the, okay, I'm sure this is the previous one, 1.5. So that's the previous one. So that is E. Tyrese, thank you very much indeed for taking the time and the trouble to also answer F. So Tyrese says 8 into 45 goes 5 times, remainder 5/8. Yes, I fully agree with you. And not only Tyrese, but also Nhlanhla, Cesar, as well as Gugulethu, Buhle, Mdlongwa as well. Tyrese, thank you so much. And of course, Lesedi as well agrees with Tyrese. Excuse me. Now that we know that 8 into 40 can go 5 times, but the remainder, if it's 45, then the remainder will definitely be 5, and then of course, this is 5 and then 5/8. And you can see that this is what we all got as the final answer. The last one is 240/50. Again, this fraction, also known as an improper fraction. So what we really need to do there is just to write the fraction in as a mixed number. So you must turn it into a mixed number there. So 240 divided by 50. And then of course, you can just check 50 goes how many times into 240. Then Nhlanhla has already answered. She says it goes 4 times. I fully agree with you, Nhlanhla, because it goes into 100 and then 15 to, it goes into 200, just to be specific. And then of course, that goes 4 times and the remainder will be 40. In fact, the remainder is 40/50. So I see that Buhle has already written it as 4 and then 4/5. That's correct, because you can simplify 40/50 and you can write it as 4/5. Gugulethu, Tyrese as well has simplified it. That's correct, Tyrese, that's the correct answer. And then Buhle as well, Gugulethu, again, I see Gugulethu wrote 4/5 there. And then Nhlanhla as well found the correct answer. Lesedi, thank you so much for taking the time to solve this problem. So this brings us to the end of our expressions here, where we were just simplifying the different versions of fractions. And of course, you can see I also have 4, whole number 4, and then 40/50. So the 40/50, you can also simplify it further and have 4/5. Right, we are done with solving or simplifying the fractions. I just want to give you now a word problem. if you can just read this word problem thoroughly there. Lindiwe has a bag of with 14 marbles. Of these, 4 are there are different colors there. So you can see that 4 are blue, and then 7 are red, and 3 are yellow. So there are different colors for every for the marbles there. And then you have got about 4 which are red there, and then in fact 4 which are 7 which are red, and then 3 yellow. And then of course I want to know what is the fraction there, or rather what fraction of the marbles are red. I see Cesar says 1, and Natalie says half, okay, or 7/14. Yes, Natalie, I fully agree with you there. Cesar as well says that it's 7/14. And Tantla says 4/14, or 7/14, or 3/4. So Tantla gave 3 different answers there. Lesedi has got, I think Lesedi has got 1/2. I see that you put it a fraction there. It appears like 12, but I think you are right, 1/2. Yes, Lesedi has just corrected there. 1/2. Google2 says 7/14. I'm glad that you can tell or look at these fractions in a manner that you have, because this will apply a lot even when you do probability in the future, or in the not so distant future. When we do probability, you are going to work a lot with such examples. So I want to take this opportunity to reflect and agree with you that when you make the observation, you can see that there are only 7 red marbles out of a total of 14. So therefore, the fraction, as you have correctly put it, Tyrese also has the answer there. I see you say 4/14. You say 2/7. Okay, Tyrese, I wanted to say, in this case, it will be 7/14. Just as Google2 has done it. I see that Google2 had 7/14, and then she further simplified the fraction to get 1/2. Because if you have 7 in the numerator and 14 in the denominator, then all that you need to do, you can just simplify. So how do you simplify? You divide 7 by 7 to get 1, and then you divide 14 by 7 to get 2, so that your final answer is 1/2, or half. Just half will be the final answer there. Right, we are done with that word problem. So thank you very much indeed, Tyrese. Now we have another word problem which we need to solve. You can see the word problem there. Every day Sihle walks a distance of about 2 and plus 3/4 of kilometers, and then he walks another half a kilometer to his grandmother's house. So when Sihle walks to school, he takes a distance of 2 kilometers and also adding 3/4 of the kilometer there to the school, and then he also walks another half a kilometer to his grandmother's house. So the key question now is, what is the total journey there in kilometers? How many kilometers does Sihle walk every day? So how will you calculate this? Obviously, I see that Butle already has an answer there. Butle says it will be 3 kilometers. But I want you to tell me, how did you find 3 kilometers? Natalie has found the correct answer there. She says it's 3 kilometers and a quarter there. So it's 3 1/4. So all that you need to do really is just to add the 2 fractions. In fact, the first one is already a mixed number. So the best way to solve this is to turn this mixed number into a proper fraction. And of course, this means you'll have to multiply 4 by 2 to get 8. Remember that 4 times 2 is 8, and 8 plus 3 is 11. So your fraction will be as follows. It will be 11 over 3 plus a half there. And thereafter, you can just simply do your math there. And then, of course, to calculate, you'll see that eventually you will have 25 out of 6. That will be the value there that you'll get. And then if you find out what is the 25, 6 goes how many times into 25, you'll see that it actually goes into 24. And just as, yes, 6 into 24. I think that will be the correct answer there, because you'll have 4 there and then the remainder. Remember that once you have 11 over 3 plus half, if you want, you can just turn the, multiply the half there by 3 over 3 so that you get 3 over 6. And then the other one, you multiply by 2 over 2 so that you get 22 over 6. So 22 plus 3 is 25. And then obviously the common denominator will be 6. So you have to now divide 25 by 6. So now if you divide by 25, if you divide 25 by 6, you'll definitely get the amount in kilometers which were taken by Sihle. So you must divide 26 by 6. So that is, so you can see that actually it will be 4. The whole number there will be 4 because it goes into 24 and the remainder will be 1 over 6. So the answer will be 4, whole number 4, and then 1 over 6. That will be the kilometer there. All right, I hope that it makes sense. Right, let's carry on now to the next one. Just to calculate a few, this is a class activity which is made up of the different fractions. I know that we are left with only 2 minutes, but if you can just quickly do the first 2 maybe, just to, and then we can look at those. So we have 1 over 3 plus 3 over 5. So those are the fractions that I want us to add together. And then of course we can look at the final answer there. So 1 over 3 plus 3 over 5. Can you quickly calculate that? And then we can look at the answer, the final answer. Then of course, you can just tell me if you are ready. And in my case, when I add the 2, I can see that Nhlanhla got 4 out of 8. In my case, Buhle also got 4 out of 8. I realized that you have added, this is the biggest misconception, which I think we will have enough time to correct maybe in the following week. I see that Nhlanhla got 4 out of 8. And then who else? Buhle also got 4 out of 8. And then Lesedi also got 4 out of 8. And the biggest misconception that you have made today is to add the numerators and then the denominators. I can see that you said 1 plus 3 is 4, and then 3 plus 5 is 8. That is not correct. Only one person so far, Lizanne, got it correct, because Lizanne has got 14 out of 15, Lizanne. Just double check. Even Lesedi, yes. I see Lesedi actually got 14 out of 15. Yes, Lesedi, that's the correct answer. I see Lizanne wrote 4. I thought it was 14. But Lizanne wrote 4 out of 15. We will have enough time to thoroughly look at this. Let's take it as our homework. Please work out all of these 5 different fractions just to calculate thoroughly, and then we can have a look at them on Monday. I hope that this will just bring us to the end of our lesson. We don't really have time. And of course, let me also indicate that this lesson is brought to you by the STEM Digital School, and of course, in partnership with the Sasol Foundation. Please feel free to engage with us at any time on our email address, which is stemdigitalschool@africateengeeks.co.za. Until we meet again next week, and just to thank everyone who has participated in the lesson through the chat group, please have a great weekend.